Hello, linear algebra student. This video is for 2.2 part 3. We're going to talk about how to do find the inverse of a matrix by elementary row operation. And in the last video, I explained why it works, because whatever that you do to the identity matrix is the same as what you do for the when you reverse it back, you will get it back. So if you do to the original one, you would actually get and you manage to get into the identity. So they are inverse of each other. So let's start. So to make this, our goal is to make this an identity matrix, right? So first of all, you can see we need a 1 in the what is it called? In the left top corner. So the first one is to exchange maybe 1 and 2, right? So we will exchange actually the whole row. So 1, 0, 3, still dot dot dot. 0, 1, 0 become now row 1, and then 0, 1, 2, 1, 0, 0 become row 2, and then 4, negative 3, 8, and 0, 0, 1 is row 3. And then what's the second one? The second one we're going to do is to get rid of the 4. So I say negative 4 row 1 plus row 3 and put it back into row 3. Right? Negative 4 row 1 become negative 4, 0, negative 12, 0, negative 4, 0. Row 3 is 4, negative 3, 8, 0, 0, 1. So I will have row 1 no change, because I'm going to put them back into row 4. 0, 1, 0. Row 2 also no change. 0, 1, 2, 1, 0, 0. And then now row 3 would be here. 0, negative 3, negative 4. And then 0, negative 4, 1. Right? Then I would do, and what do I need to get rid of? I need to get rid of, using the second row, because this is a prefix column. This is the prefix column that I want to make it now. And this is already a 1. Okay, so in your case, if it is not a 1, you want to divide or multiply anything to change this position to 1. And so if I multiply R2 by 3, R2 by 3, I want to get rid of this 0, right? R2 by 3 and then plus R3 and put it back into R3, then I would have a 0 here. So I want to get rid of this one. Earlier, I was getting rid of this one, right? So multiply row 2 by 3, it would be 0, 3, 6, 3, 0, 0. R3 is 0, negative 3, negative 4, 0, negative 4, 1. So row 1, I just copy 1, 0, 3, dot, 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 0, 1, 0. And then row 2, I don't change also, 0, 1, 2, 1, 0, 0. Row 3 will become 0, 0. So add this, 2. And then 3, negative 4, 1. Right? 3, negative 4, 1. Just want to double check. And then what do I need to? I want to make this into identity matrix. So I want to get rid of this 0, get rid of this 0. So I have 0 here already. 0, 0, 0, 0. So this is 2. So I'm going to use the last prefix column to get rid of the 0 in the top. So what is the operation that we would do? Well, we'll start off with row. Well, what happened is this one is not a 1, so the prefix column needs to be a 1. That would be better. So I'm going to do row 3 divided by 2. Put it back into row 3. prefix column needs to be 1, right? 1, 1. For identities needs to be 1. So I will have 1, 0, 3. The other, oh, nothing changed. 0, 1, 0. Row 2, no change. 1, 0, 0. Row 3 will become 0, 0, 1. 3 over 2. No, negative 2. And then 1 over 2. Yeah, it's a little tricky. You have some fraction, but this is a good prefix column. I'm going to use it to get rid of this 0. Okay. Whenever you want to clear 0 in that column, use the prefix one. Okay. So what should I do? So it will be negative 3 of row 3 plus row 1. Put it back into row 1 because I want to get rid of the 3. So that means 0, 0, negative 3. 9 over 2, is it negative? Yeah, negative 9 over 2, negative, right, negative, so it becomes 6. Negative, negative 3 over 2, that is row 3, times 3. Row 1 is 1, 0, 3, so 0 becomes 0, 0, 1, 0. So now this would become 1, 0, 0, 9, dot, dot, dot. Negative 9 over 2, 7, 3 over 2. And then the other one would be 0, 1, 2, 1, 0, 0, 0, 0, 1, 3 over 2, negative 2, and 1 half. 7, 3 over 2. Is it a negative 9 over 2? Yeah, I should do a negative 3. Yes. So now I need to get rid of this. So it would be negative 2 times row 3. Put it back into, do I have enough space? Oh, I have enough, a lot of space. Plus row 2, put it back into row 2. Okay, so what would that be? Negative 3 times, no, negative 2 times row 3, negative 2. It becomes 0, 0, negative 2. Negative 6, times negative 2, so that would be negative 3, right? And 4, and negative 1, so that is negative, and then I multiply and add to 0, 1, 2, 1, 0, 0. Put it back into row 2. So 1, 0, 0, negative 9 over 2, 7, 3 over 2, 0, 1, 0, negative 2, 4, negative 1, and then 0, 0, 1, 3 over 2, negative 2, 1 half. Let me check my answer. Negative T4, negative 1, 3 over 2, negative 2, 1 half. The 9 over 2, I'm not 100%. 7, 3 over 2. So let's try. Yeah. So this is actually, so this side become the identity. This will become A inverse. So we can check A inverse because decimal actually can find it. But you need to know at least do once to understand how to do it. So let's try 0, 1, 0, 0, 1, 4, 1, 0, negative 3. Okay, so let's do 0, 1, 4, 1, 0, negative 3, 2, 3, 8. So A inverse is, yeah, negative 9 over 2, 7, negative 3 over 2. Oh, this is a negative. I copy wrong, right? Is it a negative? Negative 9 over 2. Oh, say negative 3 over 2. 3 over 2. 3 over 2, negative 2, 1 half. Negative 1. So I think there is a copy error here. Yeah, this is a negative 3 over 2. So it propagate, yeah. So A inverse is equal to negative and then 7, negative 3 over 2, negative 2, 4, negative 1, 3 over 2, negative 2, 1 half. And the way to do it is you enter the matrix and then you do A inverse. How do you do A inverse is you just say A and then inverse like that. They will give it to you. If you want fraction, just do it this way. So this is doing it by hand, and then you can do the same thing by elementary row operation in case you don't have. Okay, so try this one. So if I want to have 0, 1, 4, 1, 0, negative 3, 2, 3, 8. Oh yeah, we did it together. We did it already, right? So by calculator, so that's how you do. You enter it into using a decimal matrix, then enter the matrix, do A inverse. If it is a B, then you do B inverse. This it would show you. So by calculator, we did is actually like this. Is whatever that we see, negative 9 over 2. Just copy. We already did 7, negative 3 over 2, negative 2, 4, negative 1, 3 over 2, negative 2, 1 half. So we can use the same thing that we use for 2 by 2 matrix to solve a system. Okay, so let's write it as a matrix equation. So write it as A, which is 1, negative 3, 1, 1, negative 1, 1, 0, negative 1, 1. X is XYZ equal to, this is not a 215, right? So to solve that, we know that XYZ would equal to what? A inverse times B. This is B. And this is A. Times 215. Oh, 215. What is A inverse? Use the calculator. So I already did. Did I? I already put 1, 1, negative 3, negative 1, all this into here. So I just need to do B inverse. B inverse is this. Okay, so B 0, 1, negative 1. Yeah. Negative 1 half, 1 half 0, negative 1 half, 1 half 1. Times 215. So A inverse times B. So let's multiply. So I have A inverse, and this is 215. So I will A inverse times C. So that will be 4, negative 1 half, 9 over 2. That's the answer. X equal to 4, Y equal to negative 1 half, Z equal to 9 over 2. Because that's this inverse, this B inverse times C. That's actually the use of, so if you have the calculator, it's very easy. The last one we're going to talk about in class because, let's try to do it. If A minus B times C is 0 and C is invertible, what do you think A and B is? So what you can do is if A minus B times C is 0. So you can multiply C inverse on this side, 0 times C inverse on this side. So this become I. So A minus B will become 0. And if that is the case, A equal to B. A グループ B。